Good morning, children. Today we are going to start the new lesson Alternating Current. In today's lecture, I am going to cover the topics average or mean value of alternating currents, root mean square or virtual or effective value of alternating current. So let us first understand what is alternating EMF. Now, as the word clears, alternating means which is changing. So EMF which continuously changes in magnitude and periodically reverses its direction is known as the alternating EMF. Similarly, the alternating current is that current which continuously changes its magnitude and periodically reverses its direction. Now, alternating EMF or the voltage, this can be represented in two ways, either in the sine form or in the cos form. So we can say that E is equal to E naught sine omega t, I is equal to I naught sine omega t, or E is equal to E naught cos omega t, I is equal to I naught cos omega t, where E and I are instantaneous value of the EMF and current, E naught and I naught peak or maximum value of EMF and current, W angular frequency, and T is the instantaneous time and omega t is the phase. So now when the curve is in the form of sine curve, now as when time t is equal to 0, then this term sine omega t will become 0 and EMF E will be equal to 0, and this is the point at point 0 on the axis. So the sine curve always start from the 0 point and the shape of the sine curve is like this. Here this point, this blue curve is representing the EMF and the green curve is representing the current. Similarly, when the curve is represented or the EMF voltage is represented in the form of cos or the cosine curve, then when t is equal to 0, then value of the cos omega t is maximum, and in that case E is equal to E naught, so the point comes at this point. So the cos curve starts from the highest point and then to the lower point. So this E is equal to E naught for the highest value EMF. I is the current which is shown by the green curve. So this is all about the alternating EMF. Now we will find the average value or the mean value of the alternating current. Now as we know that alternating current is periodically changing. It is for the positive half cycle or the first half cycle its value is positive. For the next half cycle its value is negative. So for a complete cycle, if we find the average value, then the result will come equal to 0. So we cannot find the EMF or the average mean value of the alternating current or the EMF as the complete cycle, because as the positive and negative values get cancelled each other. So to get the average value or the mean value, we will take only the half cycle. So average value or mean value over half cycle is that steady current which sends the same amount of charge in a circuit in the time of half cycle as is sent by the given alternating current in the same circuit in the same time. So this is the definition of the alternating or the mean value, average or the mean value of the alternating current. Now let us find the expression for it. Now, you know that dq is equal to I dt. Current charge is equal to current, or current is defined as the charge per unit time. So we can say dq is equal to I dt. Now I is the instantaneous values and it is represented by I naught sine omega t. So expression changes to like this. Now this is the small value of the charge. To find the total value of the charge, we have to integrate. So integrating this expression, but it is to be integrated between 0 to t by 2, because we will calculate the mean value only for the half cycle. So when we integrate this term, then the result comes to 2 I naught upon W. Now for the maths students, it is very easy to simplify this term. When they study the integration, they can easily integrate it and get the result 2 I naught upon omega. So now here we can omit the in between steps. There are only 2 or 3 steps, but we can omit these steps and directly write the integration result as 2 I naught upon omega. And in place of omega, we know that omega is equal to t upon 2 pi. That is omega is equal to 2 pi upon t. So now in place of omega, we can write this value. So when you write it, so this will change into 2 pi upon t. 2 pi in denominator, t comes over. So this results to I naught t upon pi. So this is the value of the Q for the half cycle. Now by the definition of the average value of the current AC, ACI is also equal to the charge upon time for the half cycle. So from here we can say I average is equal to Q upon T by 2, or from the definition of the average value of this, we can write that I average into T upon 2. So this time charge value of the charge and this value of the charge, both are the same according to the definition. So if we equate these two, we get the result I average is equal to 2 I naught upon pi. Now as we know that pi is equal to 22 by 7, so here I average reduces to is equal to 2 I naught upon 22 by 7. So that is 11. Now 7 by 11 is equal to 0.637 I naught. So I average is equal to 0.637 I naught, or 63.7% of the I naught. So the average value or the mean, similarly, this is the average value of the current. Similarly, we can say the average value of the alternating EMF, that will be equal to 2 E naught upon pi. So similarly, the value, average value or mean value of the alternating current is 63.7% of the E naught. Now the root mean square or virtual value or the effective value of the alternating current. Now root mean square value of the alternating current means if we have the value I, square of it, and under root of this. This is IRMS. So either we can calculate IRMS is equal to under root of I square, and I is I naught sin omega t. So either we can simplify in this way, or by the definition, root mean square value is that steady current which would produce the same heat in a given resistance in a given time as is produced by a given alternating current in the same resistance in the same time. Let us read it again, that root mean square value is that steady current which would produce the same heat in a given resistance in a given time as is produced by the alternating current in the same resistance in the same time. So to calculate this, now dH is equal to I square heat, the formula of the heat, H is equal to I square RT. So using this formula, dH small amount of heat, I square R small time dt. Now I is I naught square I sin omega t, तो उसकी वैल्यू को अगर हम पुट करेंगे then this will come to I naught square R sin square omega t. This is the small heat. So total heat H is integrating. Now here we are integrating it for the complete cycle. So integrating 0 to t I naught square R sin square omega t dt. Again math student can integrate or simplify it in a very easy manner. They can understand easily, but for the bio students it is little bit difficult. So they can use directly the result h is equal to I naught square RT upon 2, means when you integrate it you will get this result. एंड आफ्टर इंटीग्रेशन इसमें अगेन फिर वही वैल्यू यूज़ करते हैं, ओमेगा इज इक्वल टू 2 पाई/t. सो व्हेन वी यूज दिस वैल्यू देन दिस वैल्यू reduces to I naught square RT upon 2. Again, by the definition of the virtual value of the AC, H is equal to IV square RT. So we can say that these two values, they are equal to each other. So when we equate these two, the formula, the value IV reduces to I naught upon root 2. So IV, that is the virtual value, RMS root mean square value or the effective value is equal to I naught upon root 2. I naught upon root 2. Just to simplify it, multiply by root 2 in numerator and denominator, then root 2 and root 2 will become 2, and this expression will reduce to root 2 upon 2 under root 2, and under root 2 you know that 1.414. So when you divide it you will get 0.707 I naught. So I effective or I RMS or I virtual is equal to 0.707 I naught. So that is 70.7% of the peak value. Similarly, the root mean square or the virtual or the effective value of the alternating EMF, that will be equal to E is equal to E naught upon root 2 or 0.707 E naught or 70.7% of the E naught. So these two are the relations. Now note 2-3 points into this. Root mean square value of the alternating current or the EMF can be calculated over any period of the cycle since it is based on the heat energy produced. Here we have calculated it for the complete cycle, but we can calculate it for any time period, whether it is half time period or the full time period or 1/4 cycle. But for the complete cycle, the formula will be E is equal to E naught upon root 2. We cannot use the formula for the any other time period. Do not use the above formula if the time interval and the consideration is less than 1 period. Now if we draw the graph over the same if this is the sinusoidal curve for the E is equal to E naught sin omega t, since it is starting from 0, so we will say that E is equal to, it is a sine curve, E naught sin omega t. Now here this is the peak value E naught. Now E mean value is 60.7%, so it is denoted by this, and E virtual value is 70.7%. It is represented by the green curve or the green value. So this value will be the effective value, this is the average value, this is effective value, this is the average value, and this is the maximum value. Now again, the given value of the alternating EMF and the current are the virtual values unless otherwise specified, that is 230 volt or the AC. So it means that the RMS value is 230 volt. Whatever value in our house is also coming 220 volt or 230 volt, that is the RMS value. So E effective. So from here we can calculate. Now we know that E effective is equal to E naught upon root 2. अभी यहीं पे पढ़ा है, तो यहाँ से हमारे पास जो वैल्यू आएगी E naught is equal to root 2 upon into E. Now E is equal to that is E naught is equal to root 2 times of the E virtual value. E virtual value is 230. So if you put here, then the E or the peak value will come equal to about 312 volt. So we can say that peak value is more than the effective value. Effective value, if it is only 230, RMS value is only 230 volt, and the peak voltage is 312 volt, means it is very higher than the value which is coming to your houses. AC emitter and the AC voltmeter read the RMS value of the alternating current and the voltage respectively. They are called as hot wire meters. The scale of DC meter is linearly graduated, whereas the scale of the AC meter is not evenly graduated because H is proportional to I square. Now let us discuss one numerical. A light bulb is rated as 100 watt for a 220 volt supply. So when 220 volt supply, so this is the effective value or the virtual value. Here we have to find the resistance of the bulb, peak voltage of the source, and the RMS current through the bulb. So what is given? That power is 100 volt and V is 220 volt. So now just recall the formula. R is equal to V square upon E. This formula you have studied in chapter 2 current electricity as well as in your 10th class also. So by putting these two values we can get the resistance of the bulb. Now the peak voltage of the source, that is V नॉट और वी आर एम एस के बीच में अभी अभी रिलेशन हमने देखा था. तो वी पीक वोल्टेज इज इक्वल टू रूट 2 और वी आर एम एस. नाउ वी इफेक्टिव वैल्यू इज दैट इज गिवन 220 volt and root 2, when you simplify it you will get the result 311 volt. And again P is equal to I cross V. So from here I effective is equal to P upon V, and that is equal to 0.450 ampere. So from this relations we can find out the different values. On the basis of these two numericals are given. On the basis of these two numericals are given, try to solve yourself. Okay. Thank you.